Hi oceanography students, we're going to do a review here of beach processes and shorelines in Southern California. If you go to a typical Southern California beach in summer, you'll see usually that it's wide and sandy. But if you were to come back to that same beach in the wintertime, you might see that it's covered with rocks. And the issue is not where do the rocks come from, the issue is where did the sand go? And the answer is it went out there, usually just a few hundred yards offshore. And that gives us a narrow, rocky beach in the winter because the sand is out there in those sandbars offshore. But in the summertime, that sand comes back and covers up the rocks and typically produces a nice, wide, sandy beach. So there's this natural seasonal change that happens between the winter and the summer, and the reason has to do with the sizes of the waves. In the summertime, we typically have small waves that usually push the sand up toward the beach and give us a big, wide, sandy beach. But in the winter, we tend to get bigger storms, and large waves can come in the wintertime, and those big waves will break hard on the beach and sweep the sand offshore into these places that we call longshore bars. And usually in the winter is when we typically have our worst coastal erosion problems and cliff failures with the big waves and the narrow beaches that aren't protecting the cliffs from those waves. Now another thing that sand does, rather than just moving toward the beach and away from the beach according to the size of the waves, is that it also moves along the beach, parallel to the beach. And the reason for that has to do with situations where the waves arrive at the beach at an angle. You can see in this picture that the waves are hitting the beach at an angle. And the effect of that is to cause the sand to be moved to the right along the beach. And this animation illustrates this. You can see here the waves approaching the beach at an angle, and as they hit the beach at an angle, they sweep up the beach at an angle and then wash back down, up the beach at an angle and then wash back down. And the result is that the sand moves in a series of zigzaggy arcs along the beach in the direction that the waves are going. This is called longshore drift or longshore transport. And the movement of sand occurs not just on the beach itself, but also in this area called the surf zone before the waves even come to the beach, because the movement of the waves creates a current that's called a longshore current. Now, if you were to go look at the movement of sand by longshore drift along both coasts of the United States, what you would find is the net movement of sand is to the south, both along the west coast and the east coast. And the reason for that is that most of our big waves come from the North Pacific for the west coast or from the North Atlantic if you're on the east coast. So those waves come from north and they hit the beach from north to south and push the sand from north to south. Now we're going to go zoom in on Southern California here and look at the movement of sand along our coast. The sand moves south along our coast by longshore drift, or southeast because of the orientation of the coastline. But what happens is the sand doesn't just travel south along the coast forever. It ends up leaving the beach where it drains off down these areas that we call submarine canyons. And you can see them labeled here, Redondo Canyon, Newport Canyon, and then notice La Jolla Canyon down at the bottom of the image there. That's the canyon that is taking all the sand in what's called the oceanside beach compartment. Now, a beach compartment is an area that in which sand arrives at the beach, moves along the beach, and eventually leaves the beach down a submarine canyon. What we're going to go do here is go look more closely at the oceanside compartment, at a diagram that'll illustrate one of these beach compartments. So we can imagine that the sand would come down to the beach from rivers. It also comes to some degree from bluff erosion. And then the sand ends up moving south along the beach because of longshore drift. And then when the sand reaches the head of one of these submarine canyons, it ends up draining down the canyon out onto the ocean floor. And once it does that, it's pretty much gone. You can't get it back very easily. This next picture shows us La Jolla Canyon. And so the sand heads south along our coast past Cardiff and Del Mar, and eventually reaches the head of La Jolla Canyon, not very far from the beach there down in La Jolla. And that's where it heads out onto the ocean floor. Now you can actually go out to La Jolla Canyon if you happen to be a scuba diver, as I am, and if you go out to the canyon, you can actually swim out to the canyon from the beach and you can reach the head of the canyon. And if you go down into the canyon, you can actually witness this sand draining away down onto the ocean floor. It's kind of amazing to see that sand and think that that might have been sand that somebody was walking on, 10 or 20 years ago. But now it's leaving the beach system, and there's really no good way to get it back. And so that's the story of our Southern California beaches and how the sand moves on the beaches.